Okay, let's take a look at this this equation. We might as well go through our usual steps or using our table. If you are comfortable without using the table and you can do it by inspection, that's fine. Okay, KClO. Starting with potassium, potassium 1 and 1. Chlorine 1 and 1. Oxygen 3 and 2. In order to balance the oxygens, we need a common multiple. The common multiple between 3 and 2 is 6. So we want to make 6 on the left and 6 on the right. So to make 6 on the left, we need to put a 2 in front of the KCl. That now gives us two potassiums and 2 chlorines. So then we need to put a 2 in front of the KCl. And then to make this 6, we need to put a 3 in front of the O2. Now, what you should notice is that this equation is balanced. Okay, so what does this balance equation tell us? It is telling us that 2 moles of potassium chlorate decomposes to form 2 moles of potassium chloride and 3 moles of oxygen. So let's write that out. Two moles of KClO3 decomposes. Remember, this is a decomposition to form 2 moles of KCl and 3 moles of oxygen. Okay. You don't have to write this out every time. I'm just writing it out so that you start to get the understanding of what we are reading when we have a balanced equation in regards to the amounts. And remember, a mole is an amount of the substance that can be converted to units of mass using molar mass. So the moles is what allows us to relate the substances within the chemical equation using the coefficients. Okay, so think of it like a recipe. So now looking back at the question, let's look at it together. Looking back at the question, it says how many grams of oxygen is released? So meaning how much oxygen is formed when the 28 grams of the KClO3 decomposes. So I gave some hints here to help you with your thought process. In your first step, you must convert the mass of the potassium chlorate or the KClO3 to moles using the molar mass. Because remember, we cannot convert directly from grams of one substance to grams of another. So we have to use moles. So we're following this. We're starting with 28 grams of the KClO3. We want to convert it to grams of oxygen. We must follow these steps to get there. So from mass, we're going to convert to moles using molar mass. Then from moles of the KClO3, we're going to convert it to moles of oxygen using the mole to mole ratio. So following this second step, the mole to mole ratio is identified by the coefficients. Then the last step says then convert the moles of oxygen to grams using the molar mass of oxygen. So moles to mass using molar mass. Okay, we're going to set this up using dimensional analysis. But first I will write our plan. Our starting point is 28 grams of KClO3. We want to get to grams of O2, okay? We cannot do a direct conversion. So we have to do multiple steps. So the multiple steps that happen here is going from grams to moles of KClO3. Then from moles of KClO3, we're going to go to moles of O2. Then from moles of O2, we're going to go to grams of O2. Here, our first step is using the molar mass. Second step is using mole ratio. Third step is then using the molar mass of oxygen. Okay, so let's begin writing this out. Is the molar mass given? Or do I have to calculate it? Okay, the molar mass of potassium chlorate is not given in this case, but that's okay, we can calculate it. Okay, so we're beginning with our starting point, 28.0 grams of KClO3. Our first step is to convert to moles. To do that, we need molar mass of the KClO3. Okay, so I'm going to do some calculations on the side here, and we're going to look at our periodic table. Potassium is 39.1. Chlorine is 35.5. And oxygen is 16.0. Okay, so using those masses, 39.1, 35.5, and 16. So we have one potassium, so that's 39.1. We have one chlorine, 35.5, and we have three oxygens, 3 times 16.0. We add these masses together to give us our molar mass. This should give you 122.6 grams per mole as your molar mass. So when we say 122.6 grams per mole, what that is telling you is the grams per 1 mole. We put the grams on the bottom to cancel diagonally. 122.6 grams of KClO3 per 1 mole of KClO3. Cancel out the units. Now we have moles of KClO3. We want to convert to moles of oxygen. What is the relationship that's happening here? For every 2 moles of potassium chlorate, KClO3, that decomposes, 3 moles of oxygen is formed. Okay, so we're going to put 2 moles of KClO3 on the bottom here, and 3 moles of oxygen on top. Okay, so this was our 2 to 3 mole ratio. Okay, now we cancel our units diagonally here. Now we got to moles of oxygen. From moles of oxygen, we're going to convert to grams using the molar mass of oxygen. Oxygen is 16.0. There are 2 of them, so the molar mass is 32. 16 times 2 is 32.0 grams of oxygen per 1 mole of oxygen. So if you have your calculator with you, please do this calculation along with me. 28 divided by 122.6 times 3 divided by 2 times 32. Let's see if you get the same answer as I do. So what I'm seeing in my calculator says 10.962, etc. So if we have three significant figures here, 10.96 would be rounded up to 11.0. So then our answer here, I don't have enough space. Well, I do, but I'm going to write it over here. Our answer is 11.0 grams of O2 is formed. Okay. So 11.0 grams, because our answer got rounded up because of sig figs. Three significant figures here, so round to 3 sig figs. 10.96 gets rounded up to 11.0.